So hi everyone, today we are starting about like how to design Google Docs or any collaborative editor, which is anything like Figma or any text editing software, any text editing software or live software, right? Where user can collaborate and edit changes, edit their changes in real time, right? And so these are all considering as of now considering Google Docs in mind, right? Basically a text editing software or text editing tool, I'll say. So these are the main requirements that we have. Before starting, I just want to convey that this video will be in two parts. We'll start with the basic thing, and then because later on it will get much complicated, so I'll be breaking this into two parts. So let's say we'll start with the requirements, right? What we want to achieve. So first thing is what we want to achieve is users should be able to propagate. You should be able to edit the documents and have their changes propagated to the other users in real time. Obviously, this is the basic requirement that we want. Second, that their edit should be propagated in real time. So again, same thing. And then obviously the same state of eventually it will be in consistent state. So whatever each user is doing, eventually the state of the document will be consistent. That's what we want. Now let's do the capacity estimation, right? So we'll be assuming that there will be 1 billion users and there will be 1 billion documents, and let's assume that one document is being edited by thousands of the users, right, in real time. That will be a bit complicated task also, right? So our video will also go in details later on. So, and third, just assume that the doc size will be in kilobytes, right? It could be larger also. So how we maintain it, right? So let's start with the first very naive and brute force solution, right? What will be? So let's say there's a user A, there's a user B, right, who's connected to a server via WebSocket, and they have one document to write. Okay, so let's start, right? Let's say server A started writing a document, which is this one. They started editing a document. They have written some document, sending over to the server via WebSocket connection, and they're sending whole document, right? They're sending whole document server, and similarly server and there's a user B. User B is reading that document and then sending his own rights also to that document. Now, this is very straightforward solution. So what we are doing is we at each and every for that each request, right, or each write, we are sending whole document over a WebSocket connection. And before B writes so user B writes their own changes, we have to make sure that it must have received the latest state of document, right? So obviously we need to apply locking protocol, right? We need to lock that whenever user A is writing, we need to apply lock. So user A will have complete lock over this document, that only user A can complete it right. When it completed writes, then server needs to be sure that that document, that latest document version or the latest document changes should be propagated to user B in real time, and then only B can send their own rights to the server. Okay, so this is one thing. Now all of this server will send this document over S3, right? So we are connecting S3 over here, any blob storage you will say, right? So this is one thing. Now let's see what are the issues with this brute force solution, right? Obviously we are assuming document is very large. Sending this document over WebSocket connection again and again, that will be very hectic and very slow. Second thing, obviously we said that writes will be slow, but again we are applying locks also, right? And if there are multiple users, there will be multiple locks, right? In case of concurrent, there will be multiple writes if we are there concurrently writing it, right? And it's too slow, right? Each user has to wait for their own write basically, right? And it will take time to propagate also. That is one thing. Now just move forward to a I'll not say better solution, kind of a bad solution, but above that brute force solution, right? So what it will do. So again, let's say we have a user A, we have a user B, right, connected to a server via WebSocket connection. Again, let's assume, and server A has its own DB, maybe you can say it's write DB. Right, so instead of sending document, now we are sending writes, right? So what it means, we are not sending whole document, we're just sending changes, right? So let's say we have a keyword, let's say maybe you're assuming hello keyword, right? So now user A says, okay, let's say this is 0 1 2 3 4. User A says insert W at 5, insert character W at 5, right? So this change will be sent over the WebSocket connection, right? Not the whole document. Now before user B write its own document or do the changes, right? So he needs to receive this. Let's say user B want to write O at 6. So before that, he needs to get the user B needs to get this change by user A. So obviously we still need a locking protocol, and server still needs to be sure that before B is writing something, it should have received the latest version of the document, or latest write, maybe, right? The user B should have received the latest write, then only it can write that, then only it can give their own rights, basically, right? Or so, and again, this server is connected to a DB which has all the rights stored. Okay, so what is the problem with this approach? Okay, the problem is this require again multiple locks, because whenever user A is writing the document, you cannot let anyone write it, because the consistency will be all over, right? You cannot maintain consistency in that case. You have to lock the document whenever user A is writing, right? So we require lock for sure, right? And then second thing, right, the user which is receiving it, right, or needs to write the again next version, maybe, right? So now let's say user B wants to write something, right, onto that document, but before that he need to receive all the rights from user A before it could send its own right. So that is one more problem, right? And it need to be there, otherwise there will be no consistency, right? It will be all over the place. So how to get to a better solution, right? So the better solution will be, can we somehow avoid locks, right? We do not want locks at any cost, right? So what should we do? Let's see a better solution, right? Or let's see without locks how it will look like, right? So let's assume we have a server again that's connected to it's writing it's right to a DB, right? And there are two user connected, user A and user B, right? So now user A said insert something at position this, and user B sending their own operation, but we are not locking it at this time, right? So how it will be? So let's take an example, right? So let's take this example. Let's say we have a string called COD and maintain it 0, 1, 2, 3 characters. Okay, so now this string should be CODING coding. Okay, now user A sees this string and he wants to correct it, right? So what he sees, first he want to insert I at position 3. Why? Because 0, 1, 2, 3. So I should be somewhere near this, somewhere in between D and N. Obviously it will be at character 3. I will be at character 3. Okay, so user A sends insert I at position 3. Fine. Server sees it, server processes it. So now what will be our string? CODIN. That will be 0, 1, 2, 3, 4. Okay, fine. But user B also sees this same string, which is CODN. Now he wants to correct it, but before writing I, let's say he wants to process G first. Let's say he wants to insert G first at position 4. Why position 4? Because obviously G should be after N. That means 0, 1, 2, 3, 4. So G will at character 4, right? So he wants to insert G at character 4. But the problem is, right, let's say, so user A wants this, user B wants this, right? But server, let's say, assume server processed user A's change already. That means string is not CODN or CODN, right? It is CODIN. It is CODIN. Okay, this one. So now server sees user A writes first, server processed it, so it will be CODIN. Now server gets the write from B, right? A request from B to insert G at position 4. Now what will do? What is position 4? Position 4 will be in between I and N, right? So what it will do? It will insert G at position 4. So how it will look like? It will look like CODIGN. Now, which is completely wrong without locks. I guess you got the point. Now let's move. How do we solve this problem? Right? So next thing, we need to use something called operational transformation, which is very important, because currently Google Docs uses operational transformation only, right? So what this will do, right? So Let's assume there's a server again connected and it's writing their own writes to our right DB. We have user X, we have a user Y, right? So user X sends some write to server, user Y sends write to server, right? So now how it is maintaining the consistency and the ordering without even any locking, right? Locking is, we are not locking anything right over here. So how we'll do it, right? So let's assume, so how Google Docs will do it? Google Docs do it, right? Because they use OT only, operational transformation. I'm referring operational transformation as OT, right? So let's say let's say there's a new document comes, right? What Google Docs will do? They generally assign a UUID to this. Okay, they generally assign a UUID to this, right? Which is 16-bit of character. Let's say, right? They usually assign this thing. Now every time a user wants to edit a certain document, server will maintain this kind of thing, the document UUID, comma sequence number, which means, let's say document UUID will be XXX123 something, okay, started with 0 sequence number, right? Now let's say user X comes, right? User X wants to write something. Let's say he wants to write something on that document or that particular document, right? Or with this document ID. Now he inserted something at some place, right? So it maintains a state. So that means this document has one write. As user Y has its own local copy with version as 0 of the same document, okay, of the same document as version 0. So when it sends some write, let's say write 2, okay, server checks it sent x2 comma 0 with write as 2. This is what sent by user Y. It's sent. What is the latest version with user Y? It says okay, it's 0, and it wants to write this 2, let's say write 2, right? So what's the problem? The server sees okay, it doesn't have the latest copy, of the document, right? So first, before applying this write 2, before applying this operation, it needs to have the current state of document. So what it will do, before processing this write, it will send write 1 to user user Y. It will send write 1 to user Y, right? First it will get it, then it will process write 2. So what it will be? Now it will be 1 comma 2 prime. It will not be 2, it will be 2 prime. So first write from server from user 1, from user X, and second write transformated from user Y, right? So it will again transform the write 2, and then it will propagate this to every users, whatever connected to that particular document or particular server. It will propagate to each and every user connected to that document. This is how it will do it, right? There's one more thing. Which is how, let's say I'll give you the example first. Let's say there's hello written by X, and Y wants to write hello world. Okay, Y wants to write hello world, right? Let's say server sees X hello first, and it changes the document state to, it changes the, I'll rewrite it. Let's say, let's again go to more space maybe. Okay, so let's take this example. Maybe there's a document. So this is our server. So they have their own copy with doc version as 0. Similarly, Y have its own copy with doc version 0. Now X is sending something to server checks it and maintains its own state with doc version as 1 and string as hello. Okay, now Y wants to send something. Let's say he wants to send word this, something this, right? But server checks, does it have the latest copy of the document, the latest version of the document, which is doc 0? It has currently nothing because it has at version 0, right? So what it will do, first it will have hello, then it will add world to it, right? So not word first, because it sees hello first, so it will see it and then add word, and then again send it to the user Y and user X. Now I'll explain the same problem, right, with code in, right, this CODN, and it wants to be, and they want to transform it to CODING. Okay, now with OT, right, how it will work correctly, right? Let's say these are at position 1 2 3 0 1 2 3, right, and this is server X, right? Now user A sees it, user Y sees it, at same time this sees the string CODN, this is the string CODN. Okay, right? So when user A sees it, they want to insert I at position in between D and N, which is position 3. Okay, so it just sends the operation, okay, insert for this document, insert which is at version 0. Okay, what is operation? Operation will be, so it will look like this only. So what is operation and what is your doc version, something like this, with doc UUID also. So this is how usually the client send it to the server. This is how it will look like, right? So okay, so it will send insert I at position 3. Okay, so it will be CODIN. Okay, now user Y sees it, right? He wants to insert, Y wants to insert character G at position 4, because G should come after N only, and this is what it is seeing as latest string. Okay, right? So this is what user Y wants to insert. Okay, so what we will do? So user Y sends insert G at character insert character G at position 4 with doc ID and version currently at 0 as local version. Y stores local version at 0 only. Okay, fine. Now server sees it. Server sees Y's request that it wants to insert character G at position 4. Okay, and document with latest version with Y is 0, but latest version at server is already, for that doc is already at 1. Okay, so what it will do? First it will send that write to server to user Y, saying first you should have code CODING as the string, right? You should have this. So it will propagate first write from user A to user Y, right? That you should have it. Then it will apply the user's Y operation onto this string, right? So it knows how to transform. There's